We covered static variables in the first section of the course, and I will leave the link to that lesson in the description if you want to refresh your mind on static variables. In this lesson, we're going to be talking about static properties and methods of the class. So let's add a static property and a method to this transaction class. You can define your properties and methods to be static using the static keyword. So let's add a count property to this transaction class and let's make it static. So we could do public static count, and we can set the default value to 0, and let's make this an integer. Now you could put the static keyword before the access modifier or public in this case and it would still work, but if you're following standards you should put it after the access modifier, but it is up to you as long as you stay consistent. You can access static properties and methods the same way you could access constants using the scope resolution operator. So if we go to index.php, we could do var dump transaction object, scope resolution operator, and count. If we refresh the page, we get 0. The thing is, you don't actually need the object to access the static methods and properties of the class, because they're not created and they're not associated per object. They are created and are associated on class basis, so they belong to the class itself and not to any particular object or an instance. And here, as you can see, this is perfectly valid and it will work. You can access static properties and methods on the objects, but you don't have to. You could access them on the class itself the same way we're accessing class constants. So if we do transaction count and we refresh the page, we get 0. Now I mentioned that they're not associated per object. What that means is that the regular class properties like amount and description in this case, every time you create an instance, these properties get created and get associated to that specific object. So you could have multiple different transaction objects and each one can have different values for those properties. You can think of static properties as global variables in a way. Their values are shared across the objects because they're not tied to a particular object or an instance, they're tied to the class itself. So let me show you an example of that. Let's increment count every time a new instance is created. When referencing the static properties or methods from within the class, you could use either the self keyword or you could use the class name as well. So we could do self count and we could simply do ++. Now if we refresh the page, as you notice, it changed from 0 to 1. Now if we duplicate this say 5 times and we refresh the page, as you can see now it's printing 5. If we comment all of them out and we don't have any object, now it's going to be 0, which is the default value. So as you can see, the value is shared and is kind of globally accessible, right? You don't need an instance of the class, you could simply just access them using the class itself. Now let's change the access modifier to private here, and now this property is only accessible within the class and it's no longer accessible outside of that class. So if we refresh the page, we're going to get a fatal error. To fix this, we need to add a static method. So we could do something like get count, and we could create this method with the static keyword and simply return self count. If we refresh the page, everything is still working. If I go ahead and uncomment these, it will still print 5. Because the access of static methods does not require an instance of the class, and because they belong to the class itself and not to a particular object, the variable this is not available within the static method. So you cannot do something like echo this amount. You're going to get a fatal error, which makes sense, right? Because this variable refers to the calling object, but in the case of statics, we don't really have an object. So instead of using the this variable, you would have to use the self keyword. And there are 2 other keywords that you could use like parent and static, and we'll talk about those later in the course once we get to the inheritance and late static binding. So don't worry about those 2 keywords right now. I don't want to overwhelm you with too much information. Another thing you should be aware of is that if you try to use the scope resolution operator on a non-static property, you will also get an error. So for example, we have the amount and description properties here that are public. If we go to index.php and we did something like transaction scope resolution operator amount, this is not going to work. Let me delete the other 4 transactions. And if I refresh page, we're going to get fatal error because a static property amount does not exist. We only have the non-static property amount, and you cannot access non-static properties statically. And same applies to methods. If you try to access a non-static method statically, you would also get an error since PHP 8, and prior to PHP 8, you would get a deprecated message. So if I change this to process, which is a non-static method, this one, and I refresh the page, we get the fatal error because I am on PHP 8, but prior to PHP 8, you would get the deprecated message. All right, now that we've covered the basics of the statics, let's actually talk about the use cases for static properties and methods. The use of static methods and properties is generally considered a bad practice, but there are some use cases where the use of statics can come in handy. One use case for static properties is to have some sort of counter, as I did in this example, or to cache values. So it can often be used to implement a technique called memoization, which can speed up expensive operations by caching the results for later access. And I covered an example of that in the static variables lesson, for which the link is in the description and you could check it out if you want to. You might also come across a code that makes a use of static properties to implement a singleton pattern. We'll talk about design patterns later in the course, but singleton pattern maintains a single instance of a given class throughout your app execution. I'll show you the most simplest example of the singleton pattern implementation using the static properties and methods. So I have a DB class created here, and this is the most basic example of the singleton pattern. Now this is not exactly fully singleton because it does not contain things like clone and other magic methods, and the main reason for that is because we haven't covered those magic methods and I decided not to include them here, but this is the most basic one and I'll explain what this is. So we have a static property instance that is nullable, but its type is the current DB class and it's set to null by default. Then in the constructor we are accepting configuration or maybe DB credentials or something like that, and that's the property, right? That is non-static property. And notice that the constructor access modifier is set to private. This means that we cannot directly instantiate this class. If I go to index.php and I tried to get the instance of the DB by simply instantiating the DB class, this is not going to work. If I refresh the page, we're going to get a fatal error. And because of that, we have this getInstance method, which is a static method, and we can call this to get the instance of the DB class. This again accepts the same arguments as the constructor and checks if the instance is set to null. If it is set to null, it will set that property to the new instance of the DB class and then simply return that instance. So in here, for example, if we did DB getInstance and we passed in some config here, no matter how many times we call that getInstance, it will still get the same instance. And I can show that to you very easily. If I go to db.php, I could simply echo instance created with a break line, and if I refresh the page, we see that it's only printed one time. If however we change this to public, and instead of DB instance we did the new DB to create the new instance of the DB class this way, if I refresh the page, we see that it's being printed 5 times. But in the other case where we have the get instance and when we have this set to private, we're only getting a single instance. I'm only showing this to you because you will come across some code that might implement singleton pattern this way, and it does not mean it's the right way. Dependency injection is the right way, and we'll talk about it in more detail and about singleton pattern later in this course, so don't worry about it right now. Another use case for static methods would be to create some kind of utility methods that don't really need instance of the class. So maybe you had some kind of formatter class that had a bunch of methods to format your currency or format the amount or format the percent value and so on, and it doesn't really depend on the object. So if those methods are not tied to the object and they don't need the instance of the class and it makes it convenient for the developer to access them, then you could use the static methods in that way. So you could have something like format amount and pass your amount, and that would work. In that case, you don't need the instance of format because this method is not tied directly to that object. Another use case that you might see with static methods is with the factory pattern, and we'll talk about the factory design pattern later as well, but basically factory class is responsible for creating objects of other classes, and often developers implement it using the static methods. So for example, in here we are instantiating this transaction class, but if we wanted the factory to handle the instantiation and creation of this object, we could do something like transaction equals to transaction factory make and pass in the necessary arguments here, and this static make method would be responsible for creating the transaction object. Don't worry about this for now. We'll cover the factory pattern in this course, and this is not the right way either. The better way is to use dependency injection again, but I'll show you the proper way to implement the factory pattern without using the static methods. The main reason why the use of static properties and methods is discouraged is that they represent what's called a global state, which means that you can modify the data or call a static function from anywhere in the code, which can make things harder to maintain and harder to test. There are some very small niche use cases where the use of statics could make sense, but a lot of times statics are misused and dependency injection should be used instead. Also, some might argue that the use of statics is faster than creating instances of objects, which can be true, but it's a micro optimization that in most cases would not matter. Before we wrap up this video, I want to mention and show you a couple of things. One of them is that you could access static methods non-statically. So for example, if we did var dump transaction scope resolution operator get count, this would work, right? This prints 1 because get count is a static method. You could also use the object operator to access that static method and it would still work. Though I would not recommend doing this because it's not clear that this method is static, and plus you cannot access this variable within this method, so it could cause confusion and problems down the road. Another thing I wanted to mention is that you could have static callbacks or static closures. For example, if we had something like array map and we pass the callback here, right, function, and we pass some kind of array, and you do whatever you need to do in this array map function, you could set this function to be static. And the main reason why you would see somebody do this is because when you set the function to static, you can no longer access this variable. So if we move this inside the class, like transaction class, for example, if we did this somewhere maybe within the process method, when you define the callback or the closure as static, you can no longer access this variable. So therefore this amount would not work. So if we did something like var dump this amount, and let's make this array of size 1, and let's call transaction process here, and we refresh the page, we're going to get the fatal error because this variable is not available. If we remove the static keyword from here, we refresh, then everything is working. We get the text printed and we also get that amount var dumped from the array map function. So that's one of the reasons why somebody would have a static callback or a closure, to avoid having access to this variable, because from within the callback you can technically change this value, right? I could do something like this amount equals to 35, and now if we go to index.php and we var dump the transaction amount, we pass 25, but when we refresh, now it's set to 35, and this can cause some unexpected bugs and hard to debug issues. And if you were to add this static keyword here, now you can be sure that this kind of code will throw an error and not let the developer proceed. So if I refresh, we'll get that fatal error. Also, another reason why somebody would have static closures or callbacks is that it can be a micro optimization over the regular function, but don't use it only for that micro optimization. I use static closures when I want to make sure that this variable is not available and accessible in that function. This is it for this video. Thanks for watching. Hope this lesson was useful. We'll talk more about statics later once we get to inheritance and late static binding. Hit the like button if you enjoyed this video, share and subscribe, and I'll see you next time.